You ever look at a piece of machined metal and wonder how it gets so perfectly, flawlessly flat? Well, today, we're going to do just that. We're going to break down step by step how to manually program a CNC machine to mill a block of metal down to an exact thickness. Let's dive in.
So here's the big question, right? How do you take this raw chunk of metal and make it not just flat, but flat to within 1/1000th of an inch? It's kind of like trying to shave a perfectly even microscopic layer off something with an incredibly powerful tool. And that is exactly what we're about to tell this machine to do. We're going to break this down into 4 main stages. First, we'll start with the blueprint, the plan. Then, we'll get the tool into position for what we call first contact. After that, it's time for the fun part, the actual milling. And finally, we'll wrap it all up with a clean reset. Okay, let's kick things off with the plan. See, before you even think about cutting metal, you've got to think like an engineer and a programmer at the same time. This is where you lay the entire foundation for a perfect part. It all starts with the drawing. You got to ask yourself some basic questions about the real-world setup. What's the stock size? What tool am I going to use? How am I holding it in the vise? And maybe the most important question of all, where is our 0 point? That's the spot on the corner that becomes the origin for every single move we're about to make. So once we've got the physical world sorted out, we translate all of that into the machine's language. We have to tell it which tool to grab, exactly how fast to spin it, and how fast to move it across the part. Getting the spindle speed and the feed rate just right, that's the secret sauce. If you get it wrong, you can break a tool, or even worse, scrap the whole part. So this is where we're starting. Our block of metal is 1.110 inches thick. All that extra material on top, that's what we need to get rid of. And this is the finish line. We need to get that block down to a perfect 1.000 inches. That means we have to remove exactly 110 one-thousandths of an inch. Not more, not less. All right, plans locked in? Time for first contact. Now, this part is all about moving fast, but safely. The idea is to get that cutting tool right up to the edge of the workpiece as quickly as possible without actually touching it. So the first move is called a rapid move. And yeah, it's exactly what it sounds like. The machine moves at its absolute top speed. We're moving along the X and Y axes to get the tool positioned just off the corner of our block, staying a safe distance above it. The next rapid move is straight down the Z-axis. The tool plunges toward the part, but stops just a tiny fraction of an inch above the surface. And that's it for the high-speed moves. From this moment on, everything is going to be slow, deliberate, and controlled. And now it's time for the main event, the work. This is where that spinning tool finally meets the metal. We're not just going to plow through it. We're going to make a series of really precise, layered cuts to peel that unwanted material away. Okay, the first cutting move is a slow, controlled, linear feed straight down. And what's super interesting here is the depth. With this specific 3-inch face mill, the deepest you can go in one shot is 50,000ths of an inch. You can't just chew through all that material at once. You have to do it in these very precise, manageable bites. With the depth set, the tool starts its first pass, feeding smoothly all the way across the X-axis. As it goes, those spinning cutters just shear off that first 50,000ths layer, leaving this perfectly flat, beautiful surface behind it. And right away, you see the rhythm of this whole process. It's really just a simple 2-step dance. Step 1, feed down to set the depth. Step 2, cut across to remove the material. The machine is just going to repeat this loop until the job is done. So here we go again for the second pass. Step 1, the tool feeds down again, this time to a total depth of 100,000ths of an inch. And step 2, it feeds all the way back across the part, just in the opposite direction, shaving off another 50 thou. So now we've taken off a total of 100 thousandths. We are getting very, very close to our target. Now, before we make that last cut, we have to talk about something called a finish pass. See, those first cuts, those are called roughing passes. They're all about removing material quickly. A finish pass is different. It's a really light, really shallow final cut that's designed to give you that beautiful surface finish and to absolutely nail the final dimension. So, for our final pass, we're only going to take off 10 thousandths of an inch. Just 10. The tool feeds down to its final depth of Z-0.110. It's just amazing, right? The control this machine has to make such a tiny adjustment for this perfect final cut.
And there it is, that final gentle sweep across the surface. This finished pass shaves off that last tiny bit of material, and boom. Just like that, our part is now exactly 1.000 inches thick. Job done.
Okay, on to our last section, job done. The cutting is finished, but a good program is never really over until it cleans up after itself. We have to get the machine safely back to its home position, ready for whatever's next.
The very first thing we do is a rapid retract straight up on the Z-axis. This just yanks the tool high and clear of our beautiful new surface, so there's absolutely no chance of accidentally scratching it. Once the tool is at a safe height, the machine makes one last rapid move. It goes right back to the XY starting point where this whole thing began. It's home, and it's out of the way.
And the very last line of code is M30. It's a simple little command, but it's super important. It tells the machine we're done here. It stops the spindle, turns off the coolant, and basically resets everything, so it's ready for the operator to load in the next part.
And there you have it. We went from a simple plan to a set of instructions that created a perfect part. And this basic process, plan, position, cut, reset, this is the building block for just about everything in the modern world, from the phone in your pocket to parts for a satellite. It really makes you stop and think. If you had this kind of precision at your fingertips, what would you create?